This is the review for rational expressions. In this first section, we're going to reduce the rational expressions to lowest terms and state any real numbers that must be excluded from the domain. When we're simplifying, we're looking for common factors in the numerator and denominator. So in example 1, x plus 3 is in both the numerator and denominator, so we can cancel out those common factors. Once those are canceled, we have x minus 9 remaining in the numerator and 2 times the quantity x plus 9 in the denominator. Remember, the denominator cannot equal 0, so in this instance, if x were negative 9, that would cause the denominator to be 0, so x cannot be negative 9. In example number 2, the numerator is fully factored, but the denominator is not. If you focus on the denominator, we can factor out a 5 from both terms. When I factor out a 5, I'm left with 5y minus 1. Once everything's fully factored, we look for any common factors we can cancel, so we can cancel out our 5y minus 1s. In the numerator, I'm left with y plus 1. In the denominator, I'm left with 5. When I try to state domain restrictions, nothing could make this denominator 0. Therefore, our restrictions are all real numbers. In the last example, again, we need to check if we can factor. So the numerator is a difference of squares problem. And just as a reminder, difference of squares, the formula looks like this. And so when I factor, I would have x minus 2, x plus 2. After I factor, I look at any common factors. So I have x minus 2 in the numerator and denominator, so those will cancel out. And I have x plus 2 remaining. Since there's no denominator, there's nothing that could be plugged in that would make this equation 0, or the denominator 0. And so therefore, the restriction would be all real numbers. Continuing to simplify, again, we want to factor. For the numerator, I'm looking for factors of 6 that add to be 5. So factors of 6 would be 1 and 6, or 2 and 3. The ones that add to be 5 would be 2 times 3. So I can rewrite this as x plus 2 times x plus 3. In the denominator, same thing. Factors of negative 10 that add to be negative 3. So my factors of negative 10 would be negative 1 and positive 10, 1 and negative 10, negative 2, positive 5, or 2, negative 5. 2, negative 5 would add to be negative 3, so those are the factors I'll use. So x plus 2 times x minus 5. Looking for common factors to cancel, I notice we have x plus 2 in the numerator and denominator. And so I have x plus 3 over x minus 5 remaining. When I focus on the denominator, I'm noticing that if x were 5, the denominator would become 0, which can't happen, so x cannot equal 5. For number 5, when I factor, I have problems that are a greater than 1. So remember, we're going to start these by multiplying a and c to get a master product. So my master product is negative 6. Now, I'm looking for factors of negative 6 that add to be negative 1. So my choices would be negative 1 times 6, 1 times negative 6, negative 2 times 3, or 2 times negative 3. So again, which one adds to be negative 1? It's these two. Then we rewrite. So we leave a as is. We rewrite this to be plus 2x minus 3x. So we're plugging these factors in. And then we leave c as is, so minus 1. In the denominator, we're going to do the exact same thing, but before we do that, I'm going to finish factoring the numerators. So I do that by grouping. In the first group, I can factor out a 2x, and left I have 3x plus 1. In the second group, I can factor out a -1, and I'm left with 3x plus 1. When I rewrite, I can factor out this 3x plus 1, and I'm left with 2x minus 1. So this is going to be my new numerator. So I'm just going to write myself a note because we're going to factor the denominator next. When I factor the denominator, same process. I'm going to do 2 times -5. So that's -10. I'm looking for factors of -10 that add to be 9. So it's either -1, +10, or 1, -10. This group here would get me 9. So I am going to rewrite. I leave a the same, so 2x squared. I'm going to plug these factors in, so -1x plus 10x. Leave c the same. I'm going to group. In the first group, I can factor out a 1x. So I can just write x. And I'm left with 2x minus 1. In the second group, I can factor out a 5. And I'm left with 2x minus 1. Finally, I can factor out 2x minus 1, and I'm left with x plus 5. So this will be the denominator. When I rewrite, I would have 3x plus 1 times 2x minus 1 over 2x minus 1 times x plus 5. Looking for common factors, these 2x minus 1s will cancel out, and I'm left with 3x plus 1 over x plus 5. When I look at the denominator, I'm noticing that x cannot equal -5. Lastly, for example 6, I have x plus 7 over x plus 7. Those would cancel out, leaving me with 1. Since there's no denominator and the denominator can't be 0, my domain would be all real numbers. In the second section, we're multiplying or dividing the rational expressions and then simplifying, and still stating any real numbers that must be excluded from the domain. Remember, when we multiply or divide, we want to fully factor first, so looking at example 7, it's fully factored. We can then begin to cancel out any common factors, so I have x minus 2 in the numerator and the denominator. I can rewrite, so I have 3x plus 5 in the numerator and x plus 1 in the denominator. And then listing out the restriction, x cannot equal -1. Very similar for the next one. I'm going to check if it's fully factored, and it is. I want to cancel out any common factors. So I have x plus 5, x plus 5. I have x and x. I have 4 and 8. So 4/8 is really 1/2. And then if I rewrite, I have x minus 2. And I have 16. Remember, we typically write our constants out in front. And then I have 2 and x minus 5. And now that I've rewritten, I can see that I can still simplify these numbers out in front. So 16 divided by 2 is really 8. So I have 8 times x minus 2 over x minus 5. Nothing else can cancel out. And lastly, I notice that x cannot be 5 because that would make the denominator 0. Still multiplying and dividing, notice that this problem is a division problem. I'm starting the same way. I want to make sure everything is fully factored, and it is. Once I know that it's fully factored, we're going to keep the first fraction. We're going to change from division to multiplication, and we're going to flip this fraction upside down. After that, this just becomes an addition problem, and we start canceling common factors. So x minus 2 and x minus 2 cancel. 6/12 is really 1/2. When I write the remaining factors, I have x plus 2 over 2. Looking at the denominator, there's nothing that would make this 0, so the domain is all real numbers. In example 10, I have some factoring to do. So if I focus on this first numerator, I'm noticing I can factor out a 3. When I do that, I'm left with x squared minus 4. X squared minus 4 can be factored further, so it's a difference of squares. Remember, that formula looks like this. And so when I factor, I really get x plus 2, x minus 2. This denominator is fully factored, so we'll just leave it as is. Next, when I fully factor this numerator, I can factor out an x, and once I do that, I'm left with x plus 5. Lastly, when I factor the final denominator, looking for factors of negative 10 that add to be 3. So my choices would be negative 1 times 10, 1, negative 10, negative 2 and 5, or 2, negative 5. These two would add up to be 3, so those are the factors that I'll use. So x minus 2, x plus 5. Now that everything is fully factored, I look for factors to cancel out. So I have common x's, I have x minus 2, x minus 2, x plus 5, x plus 5. In the numerator, I have 3 times x plus 2 remaining. The denominator has all canceled, which means there's no restrictions. In this next example, again, I want to make sure everything is fully factored, and I'm noticing that this denominator is not. So we will factor first. This is a difference of squares, so again, this would be x plus 1, x minus 1. Now that everything's factored, I'm going to keep. I'm going to change to multiplications. I'm going to flip. I look for common factors to cancel out, so x minus 1 and x minus 1. And then I can rewrite. In my numerator, I have x plus 1. In the denominator, I have 5. Since the denominator will never be 0, there's no restriction. Example 12, I have some factoring to do. If I focus on this numerator first, I can factor out a 3t. When I factor out 3t, I'm left with t squared minus 2t minus 3. In the denominator, I can factor out a 5, which leaves me with t minus 2. In the next numerator, I can factor out a 6, which leaves me with 1 plus t. And in the denominator, I can factor out a 4, which leaves me with t minus 2. After looking one more time, I notice I can factor this more. So I'm looking for factors of negative 3 that add to be negative 2. So that would be negative 3 and positive 1. So I'll rewrite one more time. 3t, t minus 3, t plus 1, and everything else stays the exact same. Since this is a division problem, we're going to keep the first fraction, we're going to change to multiplication, and we're going to flip the second fraction. After I've rewritten, I'm looking for any common factors to cancel out. So I can cancel out t minus 2. Even though these are written backwards, if you imagine switching these spots, I'd have t plus 1, so these can cancel. I have 4/6, which I can really write as 2/3. And then I'm just going to rewrite so I can see things a little easier. So in the numerator, I have 2 times 3, which is 6. I have a t, and then I have t minus 3. In the denominator, I have 5 times 3, which is 15. 6 and 15 can both be divided by 3, so I would really have 2/5. So 2t minus 3 over 5. Since the denominator is 5, there's nothing that could make this 0, so no restrictions. In our last division problem, we're going to start by factoring. So for this first numerator, I'm looking for factors of negative 27 that add to be negative 6. So that would be negative 9 and positive 3. So x minus 9, x plus 3. For my denominator, I'm going to do 2 times negative 7. I'm going to do this over here. So that's negative 14. I'm looking for factors of negative 14 that add to be 13. So that's 14 and negative 1. I'm going to leave a the same. Instead of writing 13x, I'm going to put plus 14x minus 1x, and I'm going to leave c the exact same. I'm going to group, and I can factor out a 2x from the first group. I can factor out a negative 1 in the second group. I can factor out these matching x plus 7s. And so that denominator is x plus 7, 2x minus 1. In the next numerator, I'm going to do the exact same thing. So 2 times negative 27 is negative 54. I'm looking for factors of negative 54 that add to be negative 15. So that's negative 18 times 3. I want to rewrite, so 2x squared minus 18x plus 3x minus 27. I'm going to group, so I can factor out a 2x from the first group. I can factor out a 3 from the second group. I can factor out the matching x minus 9. And then I can rewrite over here. And then one more time, I can repeat this process for the denominator. So 2 times negative 5 is negative 10. I'm looking for factors of negative 10 that add to be 9. So 10 times negative 1. I rewrite, leaving a as is, rewriting 10x minus 1x, and leaving c the same. I group, and I factor out a 2x in the first group, leaving me with x plus 5. I factor out a negative 1 in the second group, leaving me with x plus 5. I factor out the matching x plus 5s, and I'm left with 2x minus 1, which I rewrite in the original. Now that everything is finally factored, I rewrite the problem. So I keep the first fraction. I change from division to multiplication, and I flip the second fraction. Then I'm looking for common factors to cancel out. So I have an x minus 9 in the numerator and denominator. I have a 2x minus 1 in the numerator and denominator. And then I can rewrite x plus 3, x plus 5, x plus 7, 2x plus 3. For my restriction, I'm noticing that here, x cannot equal 7, negative 7. Here you might have to do a little math. So I know that I don't want 2x plus 3 to equal 0. If I subtract 3 on both sides, and finally divide by 2, I'm figuring out that x can also not be negative 3/2. In the final section of the review, we're adding and subtracting rational expressions, simplifying, and then stating domain restrictions. Remember, to add and subtract, you have to have like denominators. So here, the denominators match. When the denominators match, you rewrite the denominator, leaving it the same. And then you write the numerator as one large problem. So 3x minus 6 plus 2 minus 4x. You're going to combine any like terms. So I have 3x minus 4x, and I also have negative 6 plus 2. When I combine, I have negative x minus 4 all over 5x minus 9. Nothing in the numerator or denominator will cancel. So lastly, I just state any restrictions. So 5x minus 9 cannot equal 0. And when I solve this, x cannot equal 9/5. In our second example, again, I'm noticing that the denominators match, so I'm just going to start by rewriting. I have x plus 7, x minus 1, minus negative 3x plus 16. Remember, when it's subtraction, you have to distribute the negative into the second fraction. So I have negative 1 times negative 3x, so that's really plus 3x. Negative 1 times 16 is negative 16. After you distribute, you can combine any like terms, so x plus 3x, negative 1 minus 16. I can't simplify any further, so state any restrictions. In the denominator, x cannot equal negative 7. In example 16, the denominators don't quite match. I could reorder this to see if that makes things any better. When I rewrite, I notice that it's very close, but the signs are still incorrect. Now that I've rewritten, when I look at this, I'm noticing that even if I factor out a negative 1 here, my signs still aren't going to match up. So there's nothing else I can do except look for a least common denominator. Remember, when you look for a least common denominator, you write down the entire first denominator. If there are any matches in the second denominator, you don't need to rewrite it. However, nothing in the second denominator matches, so I have to rewrite the whole thing. Then you want to rewrite the problem so that each fraction has a common denominator. Looking at this first one, I already have the 5x plus 1, which matches the LCD, but I need to add the negative 5x plus 1. Whatever I add to the denominator, I also have to add to the numerator. Looking at the second fraction, I already have the negative 5x plus 1, but I don't have the 5x plus 1. Again, whatever you add to the denominator, you have to add to the numerator. Now that I have a common denominator, I can rewrite as one problem. So in my numerator, I have 2x plus 1 times negative 5x plus 1 minus 3 minus 2x times 5x plus 1. We want to distribute to simplify the numerator. So I get negative 10x squared plus 2x minus 5x plus 1 minus, and remember you have to leave this in parentheses so you can distribute the negative, 15x plus 3 minus 10x squared minus 2x. I'm going to erase a little so that I have room to write, and then I'm going to distribute that negative through. When I distribute and rewrite, I'll have negative 10x squared plus 2x minus 5x plus 1 minus 15x minus 3 plus 10x squared plus 2 all over 5x plus 1 negative 5x plus 1. Then I can combine like terms. So negative 10x squared plus 10x squared will cancel out. 2x minus 5x minus 15x is negative 18x. 1 minus 3 plus 2 is 0. And the denominator is 5x plus 1 negative 5x plus 1. This is as simplified as it gets. I want to list any domain restrictions, so 5x plus 1 cannot equal 0. When I solve this, x cannot equal negative 1/5. For the second set, negative 5x plus 1 cannot equal 0. When I solve that, x cannot equal 1/5 as well. The second example for 17 is very similar. The denominators are extremely close to matching. Even if I tried to factor out a negative 1, they still won't match. So I'm going to start by listing the LCD. I list the LCD by listing the entire first denominator. I don't need to rewrite anything in the second that matches, but I do need to write any new factors. So my least common denominator would be y plus 1, y minus 1. I'm going to rewrite the problem, and I need to make sure that my first denominator matches the least common denominator. So I would need to add y minus 1. If I add y minus 1 to the denominator, I also have to add it to the numerator. I would want to rewrite the second fraction as well. I have y minus 1. To get it to match the LCD, I would have to add y plus 1. If I add something to the denominator, I also have to add it to the numerator. I would rewrite as one problem. And as I'm rewriting, I'm also going to distribute. So I would have 3y to the third minus 3y squared plus y times plus 1 minus 2y squared minus 2y. I can combine any like terms, so I have a 3y squared to the third. I have a negative 3y squared minus 2y squared. So that's negative 5y squared. I have a y minus 2y. So that's minus y. And then plus 1. I can't factor any further or simplify further, so now I'm just going to list domain restrictions. So y cannot equal 1, and y can also not equal negative 1. For number 18, I want to factor my denominators first. So I have x minus 1 over x minus 2 plus x minus 6, and x squared minus 4 will factor to x plus 2, x minus 2. Then I want to list my least common denominator, so I do that by writing down the entire first denominator. I don't need to include this x minus 2 again, so the only remaining item would be the x plus 2. Then I want to rewrite so that my denominators match the least common denominator. In this first fraction, I am missing x plus 2. Anything I need to add to the denominator, I also add to the numerator. The second fraction already has the least common denominator, so I don't need to add anything there. I'm going to distribute as I rewrite just to save some steps. So x times x is x squared. X times 2 is 2x. Negative 1 times x is negative x. Negative 1 times 2 is negative 2, plus x minus 6, all over my common denominator, x minus 2, x plus 2. Combining my like terms, I have x squared. I have plus 2x minus x plus x, so that's plus 2x. Negative 2 minus 6 is negative 8. All over x minus 2, x plus 2. Need to double check if I can factor this numerator, so I'm looking for factors of negative 8 that add to be positive 2. And so that could be factored into x plus 4, x minus 2. Rewriting my denominator of x minus 2, x plus 2. Then I want to look out for any common factors that will cancel. So x minus 2 is in the numerator and denominator, canceling those out. And rewriting, I have x plus 4 over x plus 2. My domain restriction would be that x cannot equal negative 2. For example 19, I want to start the same way, so I check to see if everything is fully factored, and it is. For my LCD, I want to write down the entire first denominator. I don't need to write any matches, but I do need to write any other non-matching factors in the second denominator. So my least common denominator would be p minus 2, p plus 1. If I rewrite the first fraction to have the common denominator, I would need to add p plus 1 to both the numerator and denominator. Rewriting the second fraction, I would need to add p minus 2 to the denominator, and anything added to the denominator also has to be added to the numerator. Then I can rewrite this as one problem. So I have 3, I'm going to distribute while I rewrite actually. So 3p plus 3 plus 5p squared minus 10p all over p minus 2, p plus 1. If I rewrite and combine like terms, I have 5p squared minus 7p plus 3 all over p minus 2 times p plus 1. Checking to see if the numerator can factor, I would need factors of 3 that add to be negative 7. and none of those factors will work, so this can't be factored. And so finally, the denominator, my restrictions would be that p cannot equal 2 and p cannot equal -1. In the very last example, I'm going to do this the exact same way, except there are 3 terms. So to start off, I want to fully factor all the denominators. My first denominator is fully factored. My second denominator is also fully factored. My third numerator and denominator are not. So in the numerator, I can factor out a y. In the denominator, I multiply a and c, and I get -60. I'm looking for factors of -60 that add to be -4. And those factors would be -10 times 6. You leave a as is. You rewrite -10y plus 6y, and you leave c. You factor by grouping. So I can factor out a 5y. I can factor out a 6. The y minus 2's can be factored out, which leaves me with 5y plus 6. Once this is fully factored, I look for an LCD, and so I'm going to start by writing down the entire first denominator. So I'm going to write 5y plus 6. Looking at the second denominator, I don't see 5y plus 6, but I do see it in the third, so I don't need to include that again. In the second denominator, I still have y minus 2 remaining, so I need to include that in my LCD as well. Again, looking at the third denominator, there's a y minus 2 present, but I've already written it down, so I don't need to include it again. So my LCD is 5y plus 6, y minus 2. I want to start rewriting these fractions so that they have the LCD. Looking at the first fraction, to have an LCD, I need to include the y minus 2. If I add y minus 2 to the denominator, I also have to add it to the numerator. Moving on to the second fraction, I have y minus 2 in the denominator. I need to add the 5y plus 6. If I add it to the denominator, it also has to be added to the numerator. And finally, in my final fraction, I don't need to add anything because the denominator is already the LCD. Then I'm going to rewrite, and I'm going to distribute as I rewrite just to save steps. So I would have 3y minus 6 minus, and since I'm subtracting, I want to keep this in parentheses, 20y plus 24 plus y squared minus y. I'll distribute the negative, so I have 3y minus 6 minus 20y minus 24 plus y squared minus y all over 5y plus 6 times y minus 2. If I combine like terms and rewrite in standard form, first I have y squared then 3y minus 20y minus y is negative 18y, and then negative 6 minus 24 is negative 30, all over 5y plus 6, y minus 2. If I try to factor the numerator further, I would need factors of negative 30 that add to be negative 18. Factors of negative 30 would be negative 1 and 30, 1 and negative 30, 2 and negative 15, negative 2, 15, or negative 3, 10, 3, negative 10. If I go through this list, none of these would add up to be negative 18. And so at this point, I can't factor any further, and I would just want to list my domain restrictions. So if I look at the first denominator and I solve, I see that y cannot be negative 6/5. For the second part of my denominator, y cannot be 2.